Hey there, welcome back to my YouTube channel. In today's video, we are going to dive deep into the fascinating world of programming and explore the difference between asynchronous and synchronous programming. So whether you're a beginner or an experienced developer, get ready to expand your knowledge. Before we jump into details, let's quickly define what asynchronous and synchronous programming mean. Asynchronous programming is a programming paradigm that allows tasks to run independently without waiting for each other to complete. It's like having multiple threads of execution happening simultaneously. This approach is ideal when dealing with time-consuming tasks or operations that involve external resources, such as network request or file input-output. Now imagine you are at a coffee shop and want to order a drink. In asynchronous programming, you place your order and continue doing other things like reading a book or checking your phone. Meanwhile, the barista starts making your drink. You don't have to wait until the drink is ready before doing other tasks. When the drink is done, the barista calls your name and you collect it. This non-blocking behavior is the essence of asynchronous programming. On the other hand, synchronous programming follows a linear flow of execution, where tasks are executed one after another, waiting for each to complete before moving on to the next task. It is like following a step-by-step recipe. Now let's go back to our coffee shop scenario. In synchronous programming, you place your order and wait at the counter until the barista finishes making your drink. Only then you can move on to the next task, like paying for your order or finding place to sit. Each step is executed sequentially, blocking the execution until completion. Now that we understand the basics, let's compare two approaches. Asynchronous programming shines when we want to maximize efficiency and responsiveness. It's perfect for scenarios where we can perform other tasks while waiting for time-consuming operations, like fetching data from an API or performing complex calculations. Synchronous programming, on the other hand, is ideal for situations where tasks depend on each other and need to be executed in a specific order. It ensures that everything happens sequentially and allows for easier debugging and error handling. Now let's look into some real-world example to understand both of these concepts. Imagine you are developing a web application that displays weather information to users. To provide accurate, up-to-date weather data, your application needs to fetch information from an external weather API. Here is how asynchronous programming comes into play. When a user requests weather information, your application can initiate an asynchronous task to fetch the data from the API. While the data is being retrieved, your application doesn't need to sit idle and wait for the response. It can continue serving other user requests, processing other tasks, or updating the user interface. Once the weather data is fetched from the API, your application can handle it and update the UI accordingly. This way, the user doesn't experience any delays or unresponsiveness while waiting for the data to be retrieved. Asynchronous programming allows your application to perform multiple tasks concurrently, resulting in improved efficiency and responsiveness. Now let's consider a different scenario where synchronous programming is more suitable. Imagine you are building an e-commerce website and when a user places an order, you need to deduct the item's quantity from the available stock. Here is how synchronous programming fits in. When a user submits an order, your application can follow a synchronous approach to ensure that stock deduction happens correctly. It starts by checking if the request quantity is available in the stock. If it is, the application detects the quantity from the stock and proceeds with other tasks, such as generating an invoice, updating the database, or sending a confirmation email. Synchronous programming ensures that each step is executed in a sequential order, guaranteeing the consistency and accuracy of the stock deduction process. If you were to use asynchronous programming in this case, there could be potential issues such as multiple order deducting the same time from the stock simultaneously or incorrect stock calculations. And that's a wrap. We have covered the difference between asynchronous and synchronous programming. Remember, asynchronous programming allows tasks to run independently, while synchronous programming follows a sequential flow. Both approaches have their place in programming world depending on specific requirement of your project. I hope you found this video helpful in understanding these concepts. If you have any question or want to dive deeper into the programming topics, feel free to leave a comment below. Don't forget to like and subscribe to our channel for more exciting programming content.